Cool, we're live. Let me there we are. Whoa, the hair's a little bit big today. Okay. And cast my cubes. That was not good. Get these guys going. Okay. And then open up lovely, because this is a lovely stream. Cool. Hey Stefan, how's it going, man? Uh-oh. I don't think I got enough water to last me this whole stream. Hello. Hey, how do I say your name? JRPOH 0H? Jerp. All right, I'll save that last little bit in case we fall upon some hard times. Jerp works. Okay, I'll go with that. Hello, Arman Gupta. Whoa, we're not even 2 minutes in. There's already 12 people on. It's better than normal. All right, we'll give it I don't know, a minute and a half or so. Then we'll get started. In the meantime, I'm going to send a text message real quick. Okay. Are you compiling this language to raw ASM? That is the hope. That's the plan. Yep. Yep. But we're not doing anything like that quite yet. Okay, so this is like, I made this last time I made up this next up.md, which I guess should have our next task, right? If I named it appropriately. Pipe out new nice spans through the AST/parser so that the checker can access them. Yes, okay, I remember this now. I remember. I think getting yourself an IR will help you a lot. Just a suggestion. You mean like for LLVM or something? I mean, I'm gonna have my own IR, sort of. Eric Wasmosi says, "Keep going." Thank you, man. Cool. Well, we'll go ahead and start. It's been about that minute and a half, I promised. So last time we kind of beefed up this whole span thing, right? It's now got this like from text. That's interesting. Oh yeah, okay, yeah. So now it's like lines and columns. So basically just two positions, like a start and an end position, which are now represented as lines and columns. All right. Cool. And then we made, oh yeah, and then somebody on stream, or somebody on YouTube commented, and I had the same thought myself, that this is a very inefficient, well, like doing this over and over again is going to be very inefficient. But I decided kind of not to optimize too much, or really avoid all unnecessary optimization until later, because it's just going to slow me down for now. So The idea, like this, basically every time I create a span, which is every time I create a token, it loops through all the bytes in the entire source code to like find the range, which isn't not necessarily all the bytes, but all the bytes up until it finds the spot. So not very efficient, but it's all right. We'll fix that later. Yaya Nasir, hey man, hey, howdy. You making a compiler or an interpreter? I'm making a compiler, hopefully. Although we're still just trying to type check some stuff. So, oh no, first we were going to, wait, what was it? I forget now. Next up, pipe out new nice spans through the AST/parser so that the checker can access them. Oh yeah. Okay, so these new nice spans are being made right here, right? So whenever we make a new token, which is every time we call this token new, right? When we're populating it with a span. So these tokens all have spans, which then the parser gets to poke around at. Over here, right? Because this guy has a vec of tokens, and each of these has a span, right? But cool project. I'll get started on a similar project separately, probably. That'd be super cool. I'd love to see it. If you get on the Discord, we'd love to. I'm sure all of us would love to see if you do it, or make your own Discord too. That's cool too. So, I assume that you do not use any libraries. Thus far, I'm only using pretty assertions, which just makes like the assert eq look nicer for tests. So that I wouldn't even count that because that's more like a dev dependency. So thus far, no, I haven't used any really, but I'm not like sold on that. Oh, you mean, but no yak. Yeah. No, I'm not using any of that stuff. I'm doing all that myself, but I'm not like opposed to the idea of pulling in some helper, like, I don't know, formatting library or something. But, all right, so I need to have the AST come out with spans, right? How is there like a good way to do that? Any good ideas, chat? Like, is there a way I could basically I need every single one of these nodes. These are all my AST nodes. I want all of them to have a span attached to them. Should I just add a span? Or does that seem kind of lame? I don't know, it kind of seems lame. Maybe that's fine. Then I have to go into like each of these and add a span. Is that the best way, or is there a better way? What does oops. Where's ICXD when we need him? What does Amulet do you guys think? Whoa, why does this happen sometimes? Chugga. Okay. Amulet. There's some sort of AST. What is this AST? Oh, here we go. It's right here. See, these don't have spans. So how did you get the spans through? Oh wait, this has a span. A binding? Oh, wait, parse block has a span. Wait, maybe they do have spans. Wait, some of these have spans. A parsed block has a span. Operand and binding have spans. But parse type arg has a span. So some of these have spans, some don't. I'm not sure why. So I guess I'll just give mine all spans. All right, so we'll say pub. I also noticed he was doing pub create stuff, which is cleaner. I mean, more verbose, but technically correct maybe. Like nobody should be consuming my parser outside of this crate. Well, except maybe the language server. Well, I don't know. We can do that later. All right, pub discarded. There is a name span. What do you mean by that, Jerp? There is a name span. Pub span. 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 This needs a span. In parse enum, one of the AST nodes in Amulet. Oh, okay. Gotcha. So maybe I just don't need a span for all of these things. That's probably why he didn't have all of those. Well, maybe we should think about that. Like, should we only add spans to the things we need spans for? We could just go back and only add spans when we need them. That would save us some work. Yeah, I think we should do that. That sounds good to me. All right, so don't add any spans preemptively, but when we need a span, say like we want to emit an error if something happens with like a bool literal, then we'll go in and add a span here. Only add spans as needed. All right, cool. I like that idea. I like it. Here we go, checker. What is this tref thing? We're not using that. Okay. Except what's this span? Checked program? Wait, why do these have spans associated with them again? Oh, this is why I thought I needed spans everywhere. But why? Why does a checked program need to carry around its span with it? I don't think it does. I could be wrong. We can always add it later. That removes the need for that. Checked program probably doesn't need one. Yeah. The others might in a second, but for now, until I need that, I'm going to take them out. Okay. So we have this check expression thing. How does one even check an expression? This whole type checker is pretty like mind-bending. Well, I guess we just match on the expression and we start with something simple like a unit. If it's an expression unit, we'll do something, right? Checked expression. Yeah, it depends on whether or not, because the unit is fine, but if we know there's a type hint, okay, so let's do this type hint thing. Type hint is an option of a type ID, right? All right. So then in here, we'll say if we have a type hint, if we have a type hint, didn't I make, so we have these scoped types on the checker. Did I make like a lookup type? Yeah. This I feel like should be a stir. Wow, that didn't actually break anything. So we'll look up the type. Okay, yeah, here we go. So check expression statement doesn't have a type hint. Pretty sure. What is the ISA that this OS will compile to? ARM64. This isn't the OS. This is the language. But Humble is going to be x86-64. All right, so we have a type hint, and then we'll say like let unit type ID equals self dot lookup type unit. Scope ID would be 0, right? This gives us a optional. I could unwrap this. That's okay, because we know we have unit. I could also just hard code. I'm going to unwrap that. So now we know we have type hint means this is the type it needs to be. Like for example, if this was my line of code, I said like foo int unit, right? This is obviously an error. This is obviously a type error, right? The type hint that would come in would be int, right? We get some ID. And then unit, I would have another ID. So now I have the ID of the hint. I have the ID of this. These need to match. So if I have that, that's fine. But if these are different, then we need to make a type error. Oh, cool. And what will lovely compile to? The same thing, x86-64 NASM, so that it can be used with the operating system, because the operating system is going to be written in lovely. That's the idea. You would probably hard code constants for the primitive types. That's not a bad idea. That's not a bad idea. Okay, we can do that. We can do that. Scope ID. How do you even do that? Const? I never do this. Static? What's the difference between const and static? Compile time constants. And then static is... Oh, that's like a lifetime thing. Okay, yeah. Const. It is gonna be hard. It's gonna be very hard, yes, but we're gonna give it a shot. Okay, so I'm gonna say const. So you wouldn't be able to run lovely executable binaries on my Mac. I'm new to computer architecture. No, you're correct. I wouldn't. Well, Mac is a little bit weird because there's this like Rosetta thing, because Macs used to be Intel, right? And so you sort of can, if you tweak some things, run like x64 on them, but it's not easy. Yeah, so it's not going to run on my Mac. I could make multiple backends for it, and then it could run different places. But for now, I'm just going to have it run on Humble. And it'll work on like x86, 64. Well, except for the syscalls might be different. Yeah, it's made for Humble for now. What am I going to name your language? It's called Lovely. Lovely. All right, const. Do you make these all caps? Int ID. Hang on. Is this gonna yell at me? Yeah, const upper snake case. Okay. Int ID. And you need to give these types. Okay. Alright, but that's not the right thing. So int is actually going to be 0, bool is 1, and unit is 2. Bool and unit. So this becomes that and that. So then when I do the lookup, here I actually don't really need that. Because now we have that. Try getting the help of AI if you're facing problems. Yeah, I use it sometimes, but even better is the help of you guys in chat. Has been way better than any AI could be. Do I recommend any book on OS? I haven't used any yet, but I know if you go to the OS Dev Wiki, there's a lot of resources on there. All right. So we have the type hint we need to check, right? So we'll say like if type hint equals, if type hint equals unit ID, right? Then this is good. Otherwise, we have a type error. Whoa, what just happened? Type error. I struggled to create a grid in C++. This created a language to flex on this, man. I couldn't even tell you what a grid is in C++. So there's different skills. More so than different levels of skills, I'd say. But yeah. All right. So we don't really need this. We'll just make this a to-do. Type error. And make another one up here, which is like to do. Oh, we need another else. This actually isn't a type error. Happy. This is also happy here. So this means there was no type hint, like there's nothing we were trying to satisfy, and so this is fine. Like you can use a unit whenever you want, as long as you're not expecting something else, right? So this would return this is supposed to return checked expression, right? So checked expression, the type ID becomes unit ID, and the data what is the data? What is this data? Checked expression data, okay. Checked expression data unit. Same thing here, right? Otherwise, I wonder if there'd be a better way to format this, because I I can't do stuff like this, can I? Do all languages use assembly as a base? I think so, pretty much. I mean, what do you mean by as a base? I think like at the end of the day, most things compile down to assembly, but a lot of them like do that via LLVM or something else, right? And they don't do it themselves. Have you added ternary operators? No, I haven't. Are you the one that was telling me I should do that before? No, there's still no ternaries. Why does that look like C? The syntax is inspired by C, but it's Rust. Nope, there's still no ternaries. All right. So then, I'm gonna give this a little helper. Impl checked, or not this one, right? Yeah, this one. Some languages use an intermediate representation such as C# or Java, which gets executed in a runtime, but ultimately that will get translated to native assembly for your platform. Exactly, yep. Or a virtual machine. Exactly. Checked expression. But at the end of the day, it ends up being assembly. Checked expression. New. Yeah, bytecode is effectively like a custom assembly, totally. New. It'll have a data, checked expression data, and type ID. Which is type ID. How's that? Return self. There we go. Most languages use some kind of backend that compile the machine code directly, but there are backends that compile the assembly. Okay, so LLVM doesn't ever go to assembly, is that what you're saying? It just goes straight to machine code? All right, there's that. And then I can replace these with something a little more terse. Checked expression new. Checked expression data unit. And then unit ID. Chris, I wouldn't worry. I wish I studied computer science. I basically taught myself Python or C++. And then Nathan says he wouldn't worry. Totally. Yeah, like there's a ton of resources out there. I never studied computer science either. Everything I've learned is just from working in it and doing it. So, all right, and then here we need to emit a type error. So we need some sort of like diagnostics. System. Sorry, I'm lifting my working on a game engine. That's pretty advanced. Not very good at keeping track of your code. Yeah. That can be tricky for sure. Okay, what do I want to do here? How are we gonna omit type errors? Maybe just have on the checker a type errors thing that's like a vec of type error. LLVM goes straight to binary. I did not know that. No ASM in between. They only have the LLVM IR as an intermediate. That's interesting. Didn't realize that. Paradox started watching my OS series. You also started working on OS based on Rust. Super cool. Yeah, mine's no longer going to be based on Rust, but that's really neat. Nathan, pretty cool. Totally. The hardest thing is learning how to structure or design your code so you can add to it easily. That's a big skill that I feel like I'm lacking in some areas. But all right, so let's make this type error struct somewhere like here. This file is getting sort of big. I wonder if I should break some of this stuff out. What are you building now? What kind of programming language? This is the language that the OS is going to be written in now. We're working on it. Yep. All right. I'm gonna break some of this stuff out. Well, I don't know. Maybe not as necessary. Well, I think it'll be good. So I'm gonna make a scopes.rs that'll have some of this stuff in it. Gonna make a, or not pub, but a mod scopes, and then gonna pull some of this stuff out into scopes, like scope ID. And this can be imported from there. Comment that out for now for a second here. Scope will end up over here. There we go. And then this like scopes type will end up over here. Cool. All right, this is getting intense. Time for the hoodie to come off. There we go. Okay. So there's all the scoping stuff, and then these probably need to be pub. Where is all this? Oh, this needs to be pub. This needs to be pub. Shoink. There we go. Okay. Subadera, hi bro, how's it going? Hey, welcome. All right, now we're gonna add type errors. So type errors. What is a type error? Start out with no type errors, hopefully. Um, type error. So it'll have, all right, it'll have a span, so we can have nice diagnostics, right? Span will be a span. And then just a message. I guess we'll start with just a message. Expected type and actual type. Oh, that's smart. Yeah, that's a good idea. Let's do that. Is that the only kind of type error though? Just an expected and a got? Probably for now. We'll start with that. That's good. Expected is a type ID. Oh dear. And got is some other type ID, right? Yeah, maybe not. Maybe not. I agree, but I can't think of what else it would be. So we'll start with this, and we can always add more later, no? Nathan, by the way, you're not on the Discord, are you? Does it return line number or is something else responsible for that? That's in this span. The span is like the span in the text file that it... You're not... Do I have a link? Let me get you one. Or I think there actually might be one in the description. Is there? Any? If not, here's another one. Yeah, we'd love to have you on there. Any of you guys, really. Please stay healthy. We don't want another humbleOS incident. That's what I'm going for. I'm going for another humbleOS incident. All right, so now we can emit type errors. Let's make like a little impulse so we can make these new, easier. Type error. Nathan, if you join the Discord and your username is different, maybe like let us know that you're Nathan, so that just so we don't. So just so we know it's you. That'd be nice. Fun new. So it'll take expected, got, and span. Your type error is an enum with different meanings. Yeah, I was thinking about that. That is maybe a better idea. Your username is made up of your name. Haha, hopefully you can tell us me. Okay, perfect. Yeah, that's great. Yeah, I like Jerp's idea. Let's do that. So enum. And then one of these will be like expected. Or I guess we could call it like type mismatch, no? Type mismatch. Which will have all this. Although I feel like the span. Okay, what if it was actually no? What if it was a struct? What if this was type error kind? Sorry, this is getting kind of complicated. What if this was type error kind, and then we had type error was this, and it had a span, which is a span, and then it had like a kind, which is a type error kind. That way everything has a span, and we don't have to thread the span through there. I kind of like this. Anybody not like this? I think this is pretty good. Could potentially expand that to the different kinds of error. So enum error has a type error plus future error types. Ooh, good idea. Yeah, we could potentially expand it. For now, I think this will be good. Type mismatch. Okay, so this is our first kind, and then if we'll type error, we'll have mismatch. Expected. Got. Yeah, good points, Nathan. But yeah, I agree. Best not to overcomplicate it just yet. Because let's try to keep this simple for now. This returns a type error. This needs a span. And this will return a type error, with the span being the span and the kind being a type error kind type mismatch. Expected being expected and got, oops, like that. How long have I been doing Rust? I figured this out the other day. It's like about a year. Well, that's like when a year ago, just a tiny bit over a year ago, I started reading about Rust, like reading the book and going through that, you know, the Rust book. But then actually writing it was maybe a little bit after that. So about a year. A little less than a year I've actually been writing it probably. I'm definitely not a Rust wizard. Okay, so there's that. All right, so now we can go make a seem very comfortable in it. It's pretty comfy. I find it a very comfy language if you like the things that it kind of forces upon you, sometimes pretty brutally. I generally find that it is sort of brutal, but I like what it's trying to get me to do. So, all right. So then in here, how are we gonna? What's like the? Making me want to learn some Rust. The pattern matching is just so nice. The pattern matching is amazing. Yep. Some good things about Rust. I kind of like Zig, which I tried recently, but everyone swears that Rust is the best language, but the syntax seems a lot complicated to me. What are some good things about Rust? I would like things that I really like, which maybe aren't the same that everybody likes. The type system I find to be super good. Swift is comparable. They're pretty similar as far as the type system goes, but like really good enums is like a huge thing for me. Pattern matching is wonderful. Being able to do this kind of thing, like if let sum, this is really nice. I don't know, it's just got a lot of nice stuff like that. Yeah, Nathan agrees. Enum types are really nice. Yeah, the enums are so good. Derp, you said your check function returns a result. Well, yeah, so that's kind of what my thought was here. But then what do I do? Because I'm trying to build this tree. So how do I build a tree if I'm just returning errors? That's kind of confusing. Do I prefer Rust or C++ to a beginner? I don't know C++, so I can't tell you. Yeah, result. Yes, I agree, Nathan. That's another huge one. Results and options are super good, and the whole question mark thing for propagating them like up like that, I find so much better than throwing, in my opinion. Because like in languages where you just like throw something and then things can throw, especially when you don't know if things can throw, Rust, a Swift is pretty good because if something throws, it's actually part of the type system. So it says like this function throws, and then you're forced to like try it or try await, you know, that kind of thing. Whereas in JavaScript, you can throw and like you don't know if it's gonna throw, and that's just horrible to me. But like typed errors like this are super good. The question mark's amazing. Zig or Rust? I've only done a tiny little bit of Zig. I'd say Zig seems quite a bit simpler than Rust, though. I think it's that's kind of one of the goals of Zig is to be pretty simple, I think. So Zig's probably easier to get into as a beginner. Does that mean it's better? I don't know, but all right. So yeah, we'll try this whole error thing. So result of a checked expression or a type error. This does seem the most intuitive way. So then these become like okay and okay, okay and okay. Here we're gonna return error, type error, mismatch. We expected the type hint, right? But we got the unit. The span, what is the span? Expr. Oh, so now we need to pass the span through. Like we said we were going to go do. Okay. Zig's comp time and way of doing generics is kind of cool. I agree. Zig's, that was pretty mind-bending for me coming from pretty standard generic based languages. That was like really different. So that was interesting. All right, so I need to return a span here, but we don't have spans on anything, so all I have is an expression, so we need to get expressions to have spans. So let's go to AST here. Expressions need to have spans. Uh-oh. I can't just add. This is such a frequent problem I have, where I want to add like a field to every single enum variant. Such a frequent cause of grief, in fact, that I'm tempted to add it as a feature in Lovely. Imagine this. I think I said this on the other stream. Like if I have a common thing up here, every single one of them has a span. Wouldn't this be really nice? And then this just like applies to everything. So no matter what kind of expression I have, it just has a span. I know there's other ways to do this, but this just seems like a better way. Exactly, like traits, but for fields. That's exactly what it would be like if we could call them field traits. Field traits. Hold on, we're gonna go to the. How are you building the AST prat parsing? Yep, prat parsing. We're gonna go to the discussion. Features. We got all these cool features, right? Any of these have we done, by the way? Inline assembly, no tabs. We already did this one. Check. Shoink. Strong type compile, fast compilation, good enums. Okay, first class functions. Traits, protocols. We kind of did this, but it's not really doing anything yet, so it's not really point. Typed errors, stack tray stuff, custom operator. Okay, here we go. Trait, field traits. Am I AI? Ooh, am I? I'll leave that up to you to decide. Field traits. I think this is gonna be a killer feature. This is what's gonna bring people to Lovely. Bring the masses. All right. In the meantime, we need to do something a little less ergonomic. So this is gonna become an expression kind. Expression is gonna be something different. I'm gonna need this. I'm gonna need this. I'm gonna make this pub struct expression, and then I have to do this. I say span is a span, and then kind is an expression kind. That becomes that. All right, expressions now have that. We're gonna have errors all over the place now. I really like how this file tree is showing me where the errors are. I feel like it didn't used to do that. All right, over here we got issues. So expression, oh dear, okay. Which file tree plugin is it? I think it's yeah, right here. NeoTree is what it's called. NeoTree. I think it's a pretty popular one. It's got some nice cool things. Like graphically it looks really nice. If you like drag this over, check this out. The text like fades behind the diagnostics. I don't know if you can see that, but this is like sort of fading. Oops. I just totally broke it. There we go. It's like kind of fading out behind. I think it's kind of a cool effect. But yeah, I mean, I just use it for the normal stuff. But it supports like renaming and like adding new things and stuff. So okay, so all right, so we gotta thread through all these spans now. So expression now. I suppose I should make a this kind of thing. Expression kind, and then span will be a span, and then we'll just have a self, kind of like that. Alrighty, okay, and then where's the first one? Oh, that's the wrong file. I want this one. Nope, this one. NeoTree, yep. Okay, I just joined. What did we get done today? Not too much yet. We're trying to work on making type errors be a real thing now. But to do that, I need to get like spans, like where these errors are coming from. So I'm kind of typing all that through my parser AST right now. So this becomes expression new, and then this becomes. This would be nice if I didn't have to do this. Okay, infix. I know there's errors all over the place. I just want to resolve one of them real quick. So, okay, okay, that, and then span. That's a to-do. All right, infix. While we're talking about good Rust features, this to-do macro is like the most killer of all features. I use it a lot. Now, whether macros are a feature or an anti-feature, that's a debate to be had. But this one in particular is really good. All right, infix. So, oh, that's what I was gonna do. So I'm gonna go to AST. Expression kind start. Import all of those. Oh shucks. That's also okay, never mind. That's not gonna work. Alright, so we do have to do expression kind. Rust macros in general are really nice compared to some C macros, so much more powerful. Yeah, for sure. For sure. They're really powerful. Just sometimes they're just like a little too magical, I feel like, but they're really, really good. Swift has pretty similar ones. Expression kind. Gotta import these things. Okay. How do we make this span? This is where it gets a little bit fun, right? So span then just becomes, I thought I had like, there we go, from text. The text We don't have this text anymore. Oh, we don't need that. We don't want the, oops. What happened? What happened? Oh. That's kind of like what I want. Okay, start. That's better. Well, I think I can just, let me go here and make him a new. From range, where start will just be a position. And then you can just do this. No? All right, and then we'll just do this. Span from range. Start will be the beginning of the left-hand side. So it'll be left-hand side dot, what is this left-hand side? Yeah. Doesn't it have a span? It does. And then it goes all the way to the right-hand side, end. Oh dear. These need to be public fields. Hold on. What's the matter here? Use of moved value. Oh no. Please don't do this to me, borrow checker. Use of moved value. Clone. Yeah, it's only a few integers. Like clone this, you mean? Wait, why wasn't that working? Oops. Oh, would I have to clone here? Well, I don't want to clone the whole expression. I want to clone. Yeah, left-hand side has been moved into the box. I'm just gonna say like let left-hand side. I'll say like start position equals left-hand side dot span dot start, and end position be the right-hand side dot span dot end, and then we'll use those in here. And then we need to clone these. You can store the start and end before moving. Yeah, okay, that's what I just did then. Yep. Cool, so this works. Which font is this? This is that like cool new GitHub one that they made. It's like a Mona space. This one. It's actually a family of fonts. I'm using a few of them depending on the context. All right, now we just gotta do this everywhere in here. In literal. All right, so this is different. We now have a new And then this becomes expression kind. And then this becomes span from range, or really, oh shucks. See, now I need to get this out of here. Jerp, you said why does this need to be cloned? No, start isn't a U size, it's a position which has a line and a column. So it's like 2 U sizes. You know, we could implement copy on it. That's not a bad idea. It's literally just 2 U sizes. Should we implement copy on it? That would make this a lot easier. What do you guys think? I think that's a good idea. Can position be copy? Yeah, totally. Let's do it. Joink. Wait, then we could just do this. Well, first let's stick with this. And then go to what is this? Span. Smart people. Alright, this should be copy. Happy. Okay, and then go over here. Get rid of both of these. And then we don't need this anymore. We can just do Nathan's gotta go. Have a good stream. Thank you so much. I don't know a case where not implementing copy isn't a good idea, but I'm no Rust guru. Well, if you have a big, like for example, this expression struct here, yeah, or something like really big, like if you're copying that every time, it's a big performance cost, isn't it? So I think people just do it for performance. You could copy wherever you wanted, but then you're just unnecessarily reallocating a ton of. Hello, darkness. You mean things that could be copied? Wait, why couldn't an expression? Can you not make an expression copy? How long have you been writing Rust? About a year. We just figured out. So this becomes left-hand side dot span dot start. This becomes left-hand side dot span dot end. That's much cleaner. Strings can't be copied because you need a memory allocation on the heap. Yeah, so it needs a deep clone. Oh, I didn't realize that about strings. That's interesting. Does it get easier? I found that it gets easier, for sure. See, but this is an expression. Alright, so I do still need actually the whole start position dance, but I don't need to clone them. Alright. Everything gets easier with practice, for sure. But I just learned something new today from Jerp here in stream, so there's still lots to learn. Like you can't copy strings. Alright. So this posed a problem here that this expect int, all it's doing is returning the int value. It's not just kind of throwing away that span. What do we want to do here? What is it that shows you the error on the line? This thingy? This was a plugin I found yesterday or the day before yesterday. It's called, I forget what it's called. I can find out really quick. Tiny inline diagnostic.nvim is what it's called. When I tried Rust for the first time, Burrow Checker made me quit. All I did was clone everywhere. I still did not understand Burrow Checker. Yes, Burrow Checker can be angry sometimes. Lifetimes and the Burrow Checker I found are the hardest things going into it. But you sort of gain a little bit of an intuition of like when the Burrow Checker is going to be mad, and then you can kind of avoid it. All right, so what should we do here? This expect int isn't giving me everything I want, so I can make this return the eye size and a span. Oh, see, everything's fundamentally flawed. I hate it when this happens. See, cur token is returning a token kind, which doesn't even have the span. We need it to return a whole token. Yep, we got issues. Folks, we got some issues. We need to do some refactoring here. Cur token, which is being used everywhere, it needs to return us a entire token. Having a good understanding of low-level memory management helps immensely when learning how the Burrow Checker works. Wisdom. Shucks. Okay. What does this expect? What's this called? Oh, we don't even have this. All right. So what if we made this return a result? This guy needs a new unexpected end of file. Oh dear. Okay. If we get a token from this, ta-da! Hopefully reference is enough. Okay. Do you find a job doing low-level programming or just for fun? Me? Yeah, my work stuff isn't very low level. So, yeah, this is mostly just for fun. Why return an error from the tokenizer? You can have valid and invalid tokens. This, well, what if I get none from here? That means I got an end of file. But I can't create an end of file because I don't have the source file. Which makes me think maybe I should have the source file. Yeah, I can have an EOF token. That's what I had before. Okay, we're doing some serious refactoring. Okay, I'm going up here. This guy's now going to hold on to, where's my parser? Parser. He's going to hold on to the token, but he's also going to hold on to the source file. Source is just a big old string. You'd probably implement iterator. It does have iterator. The lexer does have iterator. The reason... Yeah, okay. I'm doing some deep reworking of stuff here. Alright, yeah, let's try something like that. Something like that. So instead of the parser will hold on to, it won't hold on to a string of tokens, it'll hold on to a lexer. Doesn't need a position. Oh wow, all of our tests are gonna fail. Okay, and then that's why we make tests, people. I'm going to like comment all this out for a second. Just so that all the errors are from in here. So parser just takes a source. Okay. Okay, when we make a new parser now, we're going to say let lexer new. It's not going to take this anymore. It's going to take a source. And then you pass the lexer through, and we'll pass the source through. You wrote tests the first day because working language, and then gave up because I was moving too fast for me to bother updating the tests. Yeah, well, I'm not really in a hurry, and I kind of want things to be correct, so. Alright, so now we can create a new one of these things. So now we have a source, in theory, that we can hold on to. We don't really need cur token anymore because we have a lexer. Nor peak token. Nor advance. Or wait. How does one advance an iterator? How does my neovim command prompt come on the center? Like this? This is because I'm using a plugin. I forget if this comes from Snacks or Noise, but it's one of those two plugins. Yeah, is that Snacks? That's probably Snacks. Either Snacks or Noise. There, sent it in chat. Okay, does an iterator have a concept of it like a dot advance? It's noise. Well, I'm thinking we should be able to get rid of all those. This is gonna be a nightmare. That's all right. That's all right. Just keep telling myself that it's all right. All right, we're just gonna work from the top and try to fix things. So self.cur token. I don't know. What do we have? We got like a self.lexer now. What does it have? Cur next. Peak into iter. What are the methods on? What are the methods on iterators? Is lexer actually implementing iterator, or did I lie about that? Yeah, lexer's an iterator. So now it has a next. So this self.next token probably shouldn't be public, because this is what we want to be public, right? Okay, so then we can say, wait, so like self.lexer.next. Why is that not? Oh, that is a thing. It just doesn't want to complete it for me. There's a peekable iterator that has .peek. Do I have .peek? So I'm guessing that's probably another trait I need to implement. This one? An iterator with a peek that returns an optional, okay. Oh, you just do that. Wait. So if I said in here like let p equal lexer dot iter into iter, you mean? Dot peekable. Just lexer dot peekable. So this is a peekable lexer. So now I have p.next. Oh, that's now showing up. I also have p.peek. Oh. Okay, so we'll hold on to a peekable lexer. So I'll say that dot peekable. Import that. Cool, that's pretty handy. Thank you, Jerp. Make sure to give yourself the, I don't know if you saw, like the self-assignable roles in the Discord. One of them's rustation. Make sure you give yourself the rustation role. Because sometimes I'll like ping. I'll say like ping rustations, and then actually I haven't actually used it yet, but that's a nice idea. All right, now let's go through this. So now we do have those self.cur token, but then okay, so next, if I called next, because everything's gonna work a little bit differently now, right? Because if I call it .next, then it returns my current token, but it also advances, right? It does both. So, oh, and peek. And peek does the same thing, but without advancing, is that right? Rust is so well thought out, both the language itself and the standard. It's so nice. Yeah, I totally agree. The standard library is really, really good. Peek looks at the next token. But what if I want to look at the current token without returning? Wait, so if you're telling me if say you have a token here, 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 those are tokens, and I'm sitting here, right? If I hit next, it's gonna give me this guy and move me to the next one. Correct. If I hit peak, which one is it gonna give me? This one or this one? And does it consume it? Next returns the current and advances. Peak does the same without advancing. Okay, that's kind of what I thought. Sorry, peak should give you the current one without advancing. Oh, perfect. Okay, thank you so much. So this turns into, cur token basically gets replaced everywhere with, with what? Self.lexer. Lexer.peak, which returns an optional token. No, replace cur token needs to be replaced with peak. All right. Because I don't actually want to advance right here, is the thing. But here's my question. Peak returns, so some of you Rust people out there, peak returns an optional. I would love to be able to do this. Is there a way I can convert, like, is there some trait I can implement on, like, I want to be able to turn an option token none into an error, because then I would be able to like do this. Is there something like this in Rust? I don't know if there is. I've never done it. Because I know you can do things where you can turn one error type into another error type, but could I turn an option into an error so that I could then question mark chain on some of these peaks that are returning optionals? Although in this particular case, I really should just do this. But generally speaking, I'm going to want something like this. I'm going to ask the AI overlords. I have a method in Rust that returns an option token. If you can't advance, then no use of while loop and peak in it. No, because this guy right here, the parse expression statement is going to be advancing it. It does advance. That returns an option token that is being called inside a function that returns result t error, where error is my own type. Is there a way to make it turn the option into my error type so I can use the question mark? Okay, or Oh yeah, that's almost right. Except wouldn't it be some or? Oh, it is okay or. Oh, cool. Well, that's not quite what I want actually. Well, it is actually kind of one because then I could question mark it. Okay or. Oh, cool. That's nice. Okay, that is what I want. Awesome. Oh, Jerp said it. I think you can use okay or. Perfect. That is it. Needs to know what the error is. Gotcha. Needs to know what the error is. Exactly. It does need to know what the error is. But I was just wondering because you know how you can have, if I have some, say this returned one kind of error and this returned another kind of error, but I wanted to use like this on it, then there's like that trait where you can like into some other error, like one error into another error. And so you can question mark on one type of error in a function that returns a different type of error, just by passing it some way to turn the one into the other, you know? So I was wondering if there's the same thing for optionals into errors, which would be really nice, I feel like. But no, the OKR is good too. All right, we no longer have an advance. So can I just say self dot lexer dot next and ignore the result? I guess, right? So we're just ignoring the result of that. Self.cur token becomes self.peak. Sorry, self.lexer.peak. Okay, but then this is returning an optional, and I really want a token kind. Okay, so this is going to be token.peak. Oops. Okay, or error. Unexpected end of file, right? But now we have, okay, and then we question mark this. And now the problem is we have a token, and then we do dot kind. That's actually quite, would be quite nice. Except now I have that. Okay, now that's quite nice. It's a little bit lengthy, but it's very explicit. I like that. Coolio. Cur token equals self.peak. Well, first let me rename this because this is really cur token type. Or kind, really. Self.lexer.peak.okay or this guy. Whoa, that was weird. And then do that. Peak token. Peak token looks at the next one. How do I make something that looks at the next one? Because peak looks at the, yeah, returns a reference to the next value without advancing the iterator. I could advance right here. You think let cur token should advance the lexer? Picking as if you would want to branch depending on context. Oh, you mean like right here, use next? Gotcha, yeah. And then here I can just peek, because this would be peeking for the context. Is that what you're saying, kind of? Lexer.peek. Okay, or exactly, okay, cool. Error, colon, unexpected, and a file. Kind. This is becoming quite a common pattern. I'm wondering if I should well, we'll leave it for now. All right, self-thought advance. You can make a helper peek that does all that. Yeah, I thought about that. Should I? Maybe I just will. I'll make a little method down here. I'll say cur kind, because usually we just want to return the kind, right? It'll be result of a token kind. Or actually, no, it doesn't error. Yeah, it does. Rust is nice, but is very verbose. Exactly. Very nice and very verbose. Okay, this is gonna return. What does it do? You go like self.lexer.next. .okay or error, unexpected, and a file. Question mark dot kind. Sorry, this needs to be okay. This is mutt. Cool. You have my respect for choosing Rust for this task. I couldn't implement doubly linked list with Rust. I mean, but I'm sure there's some other language that you're much better at that I don't know. So I don't think it's very, very impressive. Verbosity is nice when you need it. Helps a lot to have nice error messages, for sure. But sometimes you just want to code and not see so much stuff. Totally. It's a woodpecker on my window. I think doubly linked lists are an impossibility and not unsafe for Rust. Are they? Okay, let's do. Oh yeah, peak kind, right? Peak kind, same thing, but we peak. Okay, oops. Token kind can probably implement the copy trait. No? Oh no, because that has strings. You just said I can't copy strings. I would clone it. It's a little bit smelly. It's probably all right. We'll think about that. When we get to optimizing, because they have references both ways, so at some point one won't have a connection. Oh, gotcha. That makes sense. That's really interesting, actually. What's the name of my theme? Like my Neovim theme? This is Everforest. All right. Let's go. What was that to do? Oh yeah, we solved that. Okay. Self.advanced, this becomes self.lexer.next. Oh, we were gonna replace all of okay, every time we see an okay or this becomes self.peak kind. Oh dear. There we go. Cur kind. Where else are we using this? Here we go. Peak kind. That's it now. Okay, cool. You can use find and replace. Yeah, but there are only 3 of them, and they were actually all 2 of them are the same, and 1 was different, so it wasn't quite worth it. Was this the first one? No, it's not. Okay. So what are we doing here? Parse int literal. Hey Kai, what CPU will your OS run on? x86-64 Intel is the architecture. If I follow this, can I make my language also, or is there some off-stream stuff also? If you follow this, yeah, totally, absolutely. Except for this might be the longer route to do it. I do nothing off-stream on this, so everything's here in the videos, but I'm not necessarily taking the best or the fastest route because this is my first time making a compiler, so there's probably better resources out there. But yeah, I don't do anything off-stream, so if you wanted to. Baseline or V2 or V3? I don't even know. I didn't know there was a V2 and a V3. Is there a difference between x86-64 Intel and x86-64 AMD? I don't know there was such a thing as x64 AMD. Okay, expression comes a new, wait, how are we doing this? Yeah, okay. New expression kind, right? And then we need a span from range. No, not from range. Start. Oh, this was our whole problem with expect int. That's why we did this. Expect int needs to. Yeah. Okay. Oh yeah, sorry, my bad. If that didn't make sense. Okay, so first of all, yeah, let's just fix all these cur. Okay, so cur token. Let's fix all these. Cur token becomes cur kind. Cur token. Right, these all become kind, right? Cur kind. Cur kind. kind kind Okay, there's more of these than I thought. Kind kind oops. This now needs to return a result. Okay, that's it. And then Fance becomes next, right? No, lexer. That's it. All right, we're down to only 71 errors. So now we can fix this mess. Oish. Okay, so int, yes, okay, so expect int needs to return an entire, needs to return eye size and a span. Right, we need a span. So I don't want to use cur kind here. I want to say like a let cur token equals self dot lexer dot next, right? We have an optional token. So I'm going to say if let sum token then here we have a token. All right, and then we can do this kind of thing. Shoink. Right? Shoink. Not this, but this. What's going on here? Okay. Let int literal. Oh dear. Monitor just got disconnected. There we go. Okay. This then becomes this, right? You pass the int, but we also pass the span, which is span. We just pass down the token dot span. I thought token said spans. Why is it called position? Oh, that's bad. This is bad. Token. Right here, this guy. This should be called the span. Was it to macro? What does it do? It panics with a message. Yep. It panics with a message, but it also just magically makes everything like type check. So that's really nice. Like it doesn't just throw a billion errors at you. Like this isn't throwing any type errors, which is good. Okay, and then this otherwise what would that even mean? Otherwise we didn't even get a token. So maybe I should have just done an okay or here. And then here we can just get rid of this. Ta-da! Okay, that's nicer. It type checks because it has a never return type. You know you can rename functions and variables where they're used as well, not just in the struct where they're defined. Yeah, I did know that, but every once in a while I kind of forget it. But thanks for the reminder. But yeah, I do generally do that. I don't know why I did that time. Okay. I wish you could label this, right, like span. You can't, but you will be able to in Lovely. All right. We're still at 71 errors because we fixed one and made another. So now this parse int literal will help us out. So expression new token, no, expression kind. Expression kind okay, and then span. Okay, wait, we need to do this differently. So say let int token equal self dot expect int. So now we have a that, okay. Let num span. So now this should be a span and this should be the num. Okay, perfect. So then this becomes that. This becomes num. And then this becomes span. This becomes span. Boom. That's really nice. Okay. And then we're passing the span along through there. Labeled tuples are so nice. I don't get why Rust doesn't have them yet. Yeah, totally. They're super nice. Lovely's gonna have them. I think it's in our README or something, or whatever that file is that has stuff discussion. Okay. Parse bool literal. What's the matter here? Lots of things. Okay. So we need a span. Expect token isn't returning. Probably should return a span. Paradox has got to go. Have a good stream. Good night. It's midnight where you are? Wow. It's 2:36 p.m. right here. Oh yeah, good night. And thank you. So this needs to be different. I'm gonna say let toke equal self dot the only difference between tuples and structs is that tuple members do not have names. That's not the only difference. It's that tuples are anonymous, right? And structs are always named, which is kind of the big difference, I think. More so than labels. Like Swift has labeled tuples. By the way, welcome Xavier. Self dot, what should it be? It should be next. Lexer dot next. So this gives us that thing. Okay, we need to do like a okay or now we have a token. Okay. Shrink. Oh, this needs to become be peak, because then this advances it. Although I could just get rid of that advance and make this next. That's probably better. And then this becomes toke.span. Very nice, very nice. Cool. Next one, curve precedence. This just needs to turn into that. Curve precedence shouldn't, yeah, this should have been a peak. Oh, I made a big mistake. All of those ones I changed from cur to oh yeah, that was bad. All the ones I changed from cur token to cur kind should have been to peak kind. Shucks, that's kind of bad. We'll fix those as we go. Not really. Structs need to be named as well and exist outside their uses, if you get what I mean. Totally get what you mean. Yeah, exactly. That's, to me, that's the big difference. The big difference is that the one is named and the other is anonymous. The labeling thing is just kind of like another thing. Like this should have, whoa. Oh wait, no, we don't change these. Okay. So we're down to only 69 errors now. Bool literal. Okay, so bool literal. So let me get a span here, right? Sweet. Pass the span along and then make this be false. How would a type alias fix that? Okay. This needs to be new. And we need a span, right? So we got a span from here. Okay. I'd say a language where there's no distinction between structs and tuples is like JavaScript. Like object types in JavaScript is kind of like halfway between a struct and a tuple. All right, expect ident needs to give us a span, right? Okay, so make it to give us a string and a span. Kind. That's not what we want. I'm gonna say let toke equal self dot. Now we have a token here. Guess we should rename this to token. And then here we'll say that. That's nice and zig. Yeah, that's cool. The weird thing is that Rust has anonymous structs like in enum variants, but it's like the only place they're allowed, right? If I'm not wrong. Okay, we're down to, oh, we're back up to 70 errors. Okay, that's not really what I was looking for. So now this guy, we'll say let span equals, okay, no, I'm gonna say let name span. Right? So now we have a span and we have a name. And then oops. Okay. How's that? Perfect. Parse type, expect ident. Kind of the same thing, right? And then, oh wait. No, this is different. Types don't have spans, but they should. Well, let's just not do that yet because we don't have a need for it yet. So I'm just gonna say right? Can I do this? No. I can't. I have to do this. Okay. So we're ignoring the span for now. Which, yeah, later we'll probably want it. Well, we'll just get there when we get there. All right, we're back down to 68 errors. Record low. All right, parse function call. Function call. So now we have the name and then the start. Took. So the final character of a function expression is the closing right per. Wait, not the right paren. Oh, this is the function call. Yeah, that's right. And then the start is the name, right? And so if we do something like this, new expression kind, and then here do that. Coolio, and then here we need to make a span from array, not from that, from range. The start is the start span dot start, and the end is the end span dot end. Pretty sure that makes sense. Except I put that in the wrong place. How's that? Boom, it just works. Down to 67 errors. Not gonna stop till we get this to 0. This is quite a task. This is why they make those like agent panels now and all the new GUI editors. This is the kind of stuff you make the AI do. But not me. What's the problem here? Ident, name, we need a span. Where are we gonna get our span? Where's this name coming from? Right here. Okay. What happened that you got so many errors? Some big refactor? Yep, big refactor. We're trying to pass like spans, meaning like information about where in the source file every single token is, all the way through the AST. And that also kind of exposed some other things that were maybe fixable. So we turned the entire lexer into an iterable lexer. And then we're also piping all the spans through. So a few things broke, to say the least. So this name, curve count. Okay, so I'm gonna say like let talk equal self dot curve next maybe. So this gives us a self dot lexer dot next, and then took is an option. Okay, so we need to go like okay or error unexpected. That should do the trick. Okay, and then this becomes toke.kind, except for I forgot to do this. So that's all working. And then down here, ooh, nice. Is the lexing still done in a separate pass, or is the lexing and parsing done the same pass now? Same pass now. Look, check it out. I mean, yeah, like the parser holds onto its own lexer and then just does it inside the parser. It just keeps calling out to lexer.next, and lexer is an iterator. I think it's very nice. Where is that error? Okay, here we go. So then this becomes nice. Congrats, thank you. Super cool. Building a programming language with an interpreter language is crazy. Wait, what? Building a programming language with an interpreter language is crazy. Like building one with an interpreted language as the host language. Expression new. Hi, I found this live intriguing. Not a programmer, just curious about how things are done. Where are you typing these codes in? Is it like a code editor like Visual Studio? Yes. This is an editor called NeoVim, which, yeah, it's just another editor. Pretty different from Visual Studio, but yeah, it's just another editor. Hello, Evloni Gamer. All right, so this becomes expression kind, colon, ident, and then we have, ident. And then this takes the toke.span. And that just kind of worked. With a bunch of plugins. Yep. I don't actually have too many plugins. It's just the plugins I do have are kind of overpowered. So, but yeah. NeoVim is very good. But if you download NeoVim and open it, it will not look anything like this. It'll look totally different. So, use a tile manager too? No, I don't. I mean, when I'm in the terminal, I kind of do. I use Zellage, but no, not for my Windows. I mean, sort of. I use like this. This is like just the built-in Mac OS one. And I've used like 3 or 4 different ones in the past too, but I always just don't use all the features, and they seem like too much. Like I feel like 90% of the time I just want one window full screen, and then that's like it. And then sometimes I want to split something in half, and then this I can get that from the built-in stuff. So what language is this? This is Rust. Well, I wanted to make a goal, because that actually kind of worked last time. I'm gonna make a goal of 5 super chats. Any color counts. Try to get it in the next. Probably won't go this long, but I'll set it for 3 hours. If I celebrate, guys, what would be a good goal if we reach our super chat goal? What would be a good way to celebrate? What should I do? What do you guys think I should do if we hit our super chat goal? Expression. New. Thank you, Xavier, for clarifying. I'm always a little bit, I never know what to answer when people say, what language is this? I don't know if they're talking about the language we're making or the language we're using. But still, my question holds. What should I do? I'm just gonna make it, and then I'll make the goal. Maybe I can edit it. 5 super chats, all the colors, 3 hours. Start goal. Goal's going. Okay. Expression new. Expression kind. Variable decal. Well, I was asking the language you're using now, but thanks for the clarification. Okay, cool. Yeah, the language I'm using now is Rust. The language we're making with Rust is Lovely. All right, and then this. Something broke. I broke something. Okay, it's just that, no? Wait. I think I jumped ahead too fast. Okay. Where are all these coming from? Variable declaration. I see. Okay, so these need spans. So I'm gonna say, oh yeah, okay. So name and start span, right? All right, hang on, we'll do this actually. Expression, : new, expression, kind, and then that. And then in here, we'll have some to-do span. Cool. We need to I need to make another one here, right? Let end span. I'm gonna say parse expression isn't giving me a span. So yeah, I don't know much about coding since I mostly asked ChatGPT to do all the coding, just simple codes in Python. The language you are creating now must be different from other languages, right? Like, what is it different in? Pretty much the main difference is that I'm making it. But yeah, we're gonna see. I mean, it's gonna end up being pretty different. It's basically just gonna be like a conglomeration of all the things I like, and maybe some new fun ideas too. But yeah, I can't really answer that question until it exists. But it's been fun. It's mostly just a learning experience. All right, so I have an end span. How am I gonna populate this end span? Parse expression. I need to get the end span out of this thing. So I guess expressions need to have a. They need to return. All right. So this needs to be get end span from parse expression above for the value and make new span with it. Cool. So let's go to parse expression. Okay, I need to return an expression and a span. We know that much. These things need to return an expression. This thing needs to return an expression in a span. Wow, who knew this was going to be such a... should have done this in the beginning for sure. But it's alright, it's pretty fun. Gotta stay motivated. Okay, so expression span, parse expression, parse expression. Oh dear, everything's broken now. Where do I even start? Okay. From the top and work your way down to the bottom. What did I do? I accidentally deleted that whole thing. Okay. This now has a span going along with the expression statement. I guess this needs a span. Or I guess it doesn't need a span. This could just be a that kind of thing. Nope. Okay. How's that? Good. Okay. Coolio. Do you have any plans for supporting functional programming tooling, or is it more of a data-oriented OOP lang? I'd say it's more functionally inspired than OOP inspired. But it'll probably be like multi-paradigm kind of thing, sort of like Rust-y or Swifty that can kind of do like a lot of both. All right, and then Then what? 88. We're up to 88 errors. Better than ever. If we hit 100, we win. I bet I could do it. No, that brought it down to 16. All right, 88. So next one is here. Okay, so expression now. Okay, so we need expr and we need span. Ooh, we just brought it up to 90. Let's go. We're getting close. Imperative programming lang, not functional, but with some features inspired by functional languages. Exactly. Yeah, Xavier got it. Yeah, it won't be technically functional. Correct. What is this? Oh no, we're back down to 89. That's no fun. Why is this a syntax error? That's interesting. I've never had to do that before. Oh, down to 81. Oops. Okay, the fact that everywhere we're using it, we're actually not even... Well, no, here, okay, that makes sense. Okay, here... See, like, all these need to return. Some of these... None of these are returning spans. Okay, so all these need to be returning spans. So I guess we'll start doing this. Make this guy return a span. Oh no, the expression has a span. Wait, have I been doing this wrong the whole time? Expressions have spans. Expressions have spans. Get that in your head. Okay. Expressions have spans. So this is ridiculous. Like, whatever have I been doing right here? Expression and a span? That's silly. Expressions already have spans. Oh man, this is so confusing. Okay. Get rid of that. How many errors do we have now? 73. Hey, that actually fixed some things. Okay. Now go back through and undo what everything I just did. We just want an expression. Expression already has its own span. It's fine. This just returns the expression. Oh man. Returns the expression. What's wrong with this? This is ridiculous. Well, who made this type? Who made this type? Expression. Okay, so, oh dear, oh dear. Okay. Oops, 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 oops. Okay, everything's broken. This needs to be mutt. Okay, 66. We're down to 66. Expect that. What is this? What is this? Okay, that's fine. That's fine too. Oops. This? What is this? Parse function expression. Wait, so what was our thing up here then? Expression, expression, expression. So values and expression. Oh yeah, because we can just use that. So I was just confused. We can just use the span on the value. Oh. Oh, I get it. I get it. Okay, so we have a start span, and then we have a value. Oh, okay. So this is a wild goose chase. What I hear you saying. So we can make span from range, and then the start becomes the start span dot start, and the end becomes the value dot span dot end. Ta-da! This is supposed to be copy. All right, I'll do it up here. Lit end position equal value dot span dot end. And then here I'll just use that. Boom. Okay, because it's copy. Down to still at 66. Not sure what happened there. Oops. 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 My abilities to successfully operate NeoVim go downhill the more intense the task gets. Okay. Now, parse function expression. This is interesting. Should be fairly straightforward though. New, this becomes an expression kind. If I ever get out of this mess, it's gonna be amazing. Okay, this function takes 2 arguments. Takes it to do is what it's gonna get. Okay, and then another oops. Okay. So those are actually surprisingly all happy. So then we just need to find the start and we need to find the end. So we expect that. So we're actually just gonna say, what is this return? Expect token returns a span. Okay, so we're gonna say let start span equal that. Now we have the beginning. Okay, and then at the very end we have a right brace, right? And this actually returns span 2. Okay, let end span equal that. And then here I just say span from range. Start is start span dot start. End is end span dot end. How's that? Down to 65. Okay, 65. What is this? What is this? Name? Name is the wrong thing. Okay, where is name coming from? Expect ident. You need something more like this. Ta-da! Okay. First. What is first? First. Where did first come from? Easy. Parser new tokens. What is this? This is in my tests. You trying to tell me all the rest of these errors are my tests? Wait. Oh, this was from when we were on that silly goose chase earlier. Okay. Oops. Just lost all my work. Just kidding. Okay. Wait, there's no more errors. Okay, so this is pretty much all in our tests. So let's go fix all of our tests, which is going to be a total nightmare. All right. So this whole new thing. Wait, that's fine. Parser new. Okay, so this expect AST turns out it's different. We don't actually need any of that anymore. We say parser new. We just pass it the input. Ta-da! Much simpler. We no longer need any of that. And then we're down to 60. Okay, and literal. Like what's the difference? Oh no. You tell me you have to make a span for every single one of these? Brutal. Just brutal treatment. All right, but it will make the tests better. All right. So this becomes an expression or new expression kind. Oops. Okay, patience. Okay. New. Let me give it a span. So span is going to be like a span. What is a span? Joink. Okay. Span from range or from text, which would be easier? Probably in this case a text. I need to pass it the text. Good grief. Let's try range. Much better. But now I have to make positions. Uh-oh, we got an extra parentheses on the loose. Okay, and then from range, position from char and oh no. All right. This is very nice, but I want a better one. line call, line usize, column usize. I just want self with line and column. Thank you very much. All right, now I can do this. Line column becomes line 1, column 1. 2, position line call 1, 3. And now for my next trick, I'm going to comment out all the rest of the tests and see if this one is working. That's what I thought. Well, folks, that to me looks like a perfect stopping point. I think I'm ready to be done with this stream, but it's been a ton of fun, and thank you all for all the help. Next stream, we will continue fixing all these tests and debugging why this isn't working, but at least we got most of that refactor hopefully kind of done, although we clearly got some things wrong. But cool, see you all next stream and on Discord. Until next time.